All right, good morning, good afternoon, good evening, whatever time of the day it is. Welcome to your lab. That's right, today we're doing a virtual lab called Dino Dig. And the idea is for you to practice being a paleontologist. A paleontologist is a scientist who studies extinct animals. So think of Jurassic Park, those scientists, right? They dig up fossils and study fossils, and that's what a paleontologist does. So today we're going to do that. And you're going to learn some of the science behind that. And who knows, maybe you discover that you like it, you're good at it, and you want to go up and be a paleontologist. So let's get into this. So when you open the template, you'll see there's a link to the virtual lab. You have to have Flash enabled in your browser. And so if you open it up and it says Flash is not enabled, then you have to click on it, and it should enable it right there. And if it doesn't, you can follow the link to this article that explains how to enable Flash on your browser. It's pretty simple. So, but let's assume you get it working, and you click on the link, and here is your lab. So you see there's you read through the purpose here, read through the background. It's got a bunch of information for you that you'll need to answer the questions later. But when you get down to the procedure, I just want to explain and demonstrate what you're going to do. We'll do the first one together, and then you can do the other 4 samples on your own. So what you do is you examine the fossil. Here's the fossil right here. And you use the ruler to estimate the size, right? So from here to here is 50 centimeters. And if you look, it takes up about half of that, right? If you were to move that over. So it's about 25 centimeters, 25, 30 centimeters. And then what we need to do is we need to write down this information in our data table. So this is an unknown fossil found in Solnhofen, Germany. So go back to your lab. Oops, sorry, wrong one. Go back to your lab right down here and put in the fossil information. Just put in that name, right? Solnhofen, Germany. Solnhofen, Germany. That's where it was found. And now you see we need to figure out 4 things. The date of the rocks below, the date of the rocks above, and then that will allow us to figure out about how old that fossil is and the geologic time period from which it comes. And then we have to figure out the species of the dinosaur. So let's talk about absolute dating. It can be a little bit confusing. It deals with a little bit of chemistry, and you have to use a little bit of math. So as the procedures say, we're going to take a rock from the layer below the fossil, and we put in this thing called the mass spectrometer. Now, mass spectrometers are really cool pieces of equipment. What they do is they analyze rock samples or any other material, and they tell you what chemicals are in there and how much of each one. So when we click the start button, right, it tells us that for the isotope C, which has a half-life of 80 million years, there is about 25% of that left. And the daughter isotope, which is what the isotope decays into, is up to about 75%. And so just let me real quickly explain. An isotope is a chemical that breaks down, right? Like an ice cube melts and turns into water. Right? The same thing happens with isotopes. They start as one chemical and then they slowly melt or transform into another one. And they do that at a specific rate. So if you think about an ice cube and say it takes 10 minutes for that ice cube to melt, right? So if you come in and you see that there's about half an ice cube and half the amount of water, then you can estimate that that ice cube has been sitting there for about 5 minutes, right? If it takes 10 minutes to melt completely and it's half melted, then it's probably been sitting there for about 5 minutes. That is exactly the way we use isotope decay. in breaking down. So how do we figure this out? Well, this rock, right, has 25% of isotope C left in it, okay? And it takes 80 million years to break down halfway. So here we can think about, right, to get down to 50%, that would be 80 million years, right, because that's half. And then it went down to another 25. Well, that's half of 50, right? So that's another half-life. So it took 80 million years to get to 50%, and then another 80 million years to get to 25%. So that's a total of 2 times 80 million years. So that's 160 million years. So this rock is about 160 million years old. And that's what we write down in our data table, 160, and then we abbreviate, million years old. Okay, now what about the rock above? All right, so now we take this one out, put in the other rock. This is the one that comes from above. Same thing. And it tells us that, first of all, it's a different isotope. It has a different half-life of 130 million years. And we see that there is 50% of it left. Well, that's half, right? And that's what a half-life is. So it takes 130 million years to drop down to 50, and that's where it is. So this fossil must be about 130 million years old. So we'll write that down here. 130 million years old. Okay, so now we know we can figure out the geologic time period, right? We know that this fossil was in between 130 and 160 million years old, right? So somewhere in between there. So now what we do is we go to this geologic time scale, right? And here at the bottom it tells us millions of years ago, and we find our region, right? And again, it was between 130 and 160. So let's see, here is, right, 144 million years ago, and here's 65 million years ago. So it's earlier than this, and also later than this, right? That's 144, right? Cuts it off right here. And then 206 is the end of the Jurassic. So it's somewhere in this era. So we can say it's from the Jurassic era. Geologic time period, the Jurassic. And did I spell that right? I always spell, yeah, 2 S's. Jurassic, right? Hey, Jurassic Park. All right, and now we need to figure out the dinosaur species. So what we do now is we have to compare our fossil to the dinosaur guide. So let's have a look in here, right? So clearly it doesn't look like that at all, right? It does not look like a skull. If you look at it closely, it looks, kind of flat, and then it just has the impressions of some lobey shaped things, right? So let's look a little more closely. It's not one of this, right? And here's the whole body of one. It is not a whole body lizard. It's not a skull. It's not got this triangular plate thing here. Kind of, if you look here, right? Archaeopteryx, right? Lived in the Jurassic, so that works out. And feathers. So you see these impressions of feathers here. That's kind of what this looks like right here. Right? Those look like impressions of feathers. So, right? If we look at the other pictures, there's nothing else that it really resembles. So we'll go with that. Archaeopteryx. Right? So I'm going to say that it's Archaeopteryx. 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 Cool? All right. And once you're done with that one, you click on Reset. and it gives you another fossil. And you just do the same steps. And then when you're done, you have journal questions to answer, and then you turn that in just like you would submit any Google Doc. All right, so it's a little, I know that calculating absolute value can be a little bit tricky. That's why I put a little tutorial on it right here. And if you guys have any questions, if you're confused, send me a message through Schoology and I'll get back to you as quick as I can. All right, have fun, you guys, and stay safe and be good.